Hello, it's Dave Giles here again for the next lesson of Cambridge International Education, IGCSE Physics, and we're looking at the electricity unit and fairly short lesson looking at the difference between electrical conductors and insulators. And today we're going to make a plan to conduct an experiment to find out if a material is an insulator or a conductor and describe the differences between electrical conductors and insulators. So, for the practical drawn, take off. For this practical, we're going to do, so we're going to look at a way of finding the difference between an insulator and a conductor. We're going to use this circuit here, this one here. And you can see we have got a test substance, we've got a light bulb, and the light bulb comes on, and that means it's an conductor, and if it doesn't turn on, then it means we've got an insulator. So I want you to think about what these three variables are here. The independent, dependent, and control variable. Okay, so in case you're not sure, you need a little bit of help. An independent variable is the one we change. Dependent one is the thing we measure. And control variables are the things we keep the same. Now, you can do it with a light bulb. You can also possibly change it for an ammeter as well, and maybe an ammeter might give you some slightly better results. So an ammeter is a device which measures current. So our independent variable, the thing we change, is the object placed in the circuit. The dependent variable is either the current, if we use an ammeter, or whether the bulb will light up or not, if we just use a bulb. Things to keep the same. We need to use the same size batteries. We need to use the same bulb if we are using a bulb instead of an ammeter. And when you conduct this experiment, these are the results you will find. These objects here are insulators, so the bulb didn't light up. These are conductors, so the bulb did light up. The pencil I have put on twice, because it depends on where you place the ends of the crocodile clip. So you hold them in place here with crocodile clips. And if you place the pencil, so it's touching the wood part, then it will be in an insulator. However, if you sharpen both ends, so you've got what used to be called lead, it's not lead, it's graphite, in the pencil, then you place the crocodile clips on there, you'll find it is an insulator. So that's the first objective, describe the difference between the first objective finished, plan and conduct an experiment to find out if material or an insulator is an insulator or conductor, and these are the results you'll get. And moving on to the second objective, describe the difference between electrical insulator and conductor. So we've listed some here, you can read them yourself, some things that are insulators and conductors. Now we're going to look at why. So metals, generally speaking, are good conductors of electricity. And this is why. It's because metals have got something called free electrons. So electrons and metals are free moving, delocalized. If you do chemistry, you might see that word. And you get what's called a sea of electrons. Okay, so in a metal, you get both the atoms, or rather ions here. So these big ones are the ions, and the small ones here are the electrons. They both vibrate and pass the energy along, which is what the current is, the flow of the charge. So you do get the big ions moving, but much, much slower than the electrons, because the electrons are so much smaller. So most of the current is from the flowing electrons. You can see here, this here is a good conductor at the top, because you've got lots of free electrons, and this one at the bottom is not such a good conductor, or rather an insulator. Let's take a look at the difference between conductors and insulators. So in a conductor, it allows the flow of electricity, An insulator does not. Now, I should maybe say instead of electricity, probably say current might be a better way to word that. Has free moving electrons, conducting electrons. An insulator does not. Some examples are iron, copper, graphite. So the first two are metals. This is one of the ones which isn't a metal, but it is a conductor. Some examples of insulators are glass, wood, and plastic. So today is quite a short lesson. So I want you to have a go at these questions here. Just pause it for a moment. First one is a paper 2 question, and the next one is an exam style question from paper 4. Okay, and you should have unpaused it now, so I will give you the answers. So the first question, a student tests the electrical conduction of 4 metals, aluminium, iron, plastic, and silver. Sorry, 4 materials, not 4 metals. Which materials are good conductors for electricity? So that would be the metals. And the only one now which isn't a metal is plastic. So it's the one without plastic in. So it's aluminium, iron, and silver. Next question. What name do we give to the type of material that allows electrical charge to pass through them? They are conductors. Give an example. There's lots, but generally a metal or a named metal or graphite. So you might have put metal or you might have put copper, aluminium, etc. What name do we give to the type of material that does not allow electrical charges to pass through it? It's an insulator. Give an example, and there's so many, I couldn't put one here. Stuff like wood, plastic, etc. Which of the 2 types of material in A or B part 1, so conductor or insulator, may be held in the hand and charged by friction? That would be an insulator. Okay. So like I said, today's lesson was quite a short one. I will post the next lesson fairly soon, which will be on Ohm's law, and I'll post the link down below. Thank you very much, everyone, and I will see you in the next lesson. Thank you very much, and goodbye.